Welcome! If you want to understand why reality might be far bigger, colder, and less comforting than anything we were prepared for, stay with us until the end of this video. Because by the time we finish, the idea of a single universe may feel embarrassingly small. Right now you're inside one universe, one version of reality, one outcome. But modern physics keeps pointing to an uncomfortable possibility. This universe may not be special, it may not be unique, it may not even be rare. For most of human history, we believe the universe was everything. One cosmos, one stage, one story. Then we discovered galaxies, then billions of them, and every time we thought we reached the edge, the universe reminded us that our imagination was still too limited. Now we face the next escalation, the multiverse. Not a metaphor, not science fiction, a consequence of equations that actually work. Let's begin where the story usually starts, the Big Bang. We are told the universe began as a hot, dense point and expanded outward. That part is solid, but what often gets skipped is this. The equations do not say the Big Bang was a unique event. According to cosmic inflation, space itself expanded exponentially in the earliest moments of existence, faster than light, faster than causality, faster than any intuitive picture we can form. And in many versions of inflation, this process never truly ends. Inflation stops locally, creating a universe like ours. But elsewhere, it continues, forever. Each time inflation stops, a new universe is born, not sequentially, simultaneously. This gives us the inflationary multiverse, an endless collection of universes, each isolated, each real, each governed by potentially different physical laws. Some universes may differ only slightly from ours, others may never form stars, some may collapse instantly, others may expand too fast for matter to organize. Our universe is not central, it is just one bubble among many. Now pause here, because this already breaks something deep in the human mind. We are used to thinking in terms of one reality, one history, one timeline. The multiverse does not care about that preference, and this is only the first layer. Let's move to quantum mechanics. Quantum theory does not describe a clean, deterministic world. It describes probabilities, superpositions, multiple outcomes existing at once. The uncomfortable part is this: the mathematics never says those extra possibilities disappear. That leads to the many worlds interpretation. According to it, every quantum event splits reality. Every possible outcome occurs, each in its own universe. No collapse, no deletion, just branching. In one universe, an electron goes left. In another, it goes right. In others, variations beyond our intuition play out. Scale that up, every decision, every interaction, every moment. Reality fractures constantly. If this is true, the multiverse is not distant or abstract. It is unfolding everywhere, all the time. Which raises a brutal question. If every outcome happens somewhere, what makes this one matter? Physics does not answer that, but it forces the question onto us. Now let's add another layer, string theory. In an attempt to unify gravity with quantum mechanics, string theory proposes that the fundamental building blocks of reality are not particles but vibrating strings. To make the math work, reality requires extra dimensions, not visible dimensions, hidden ones. And the way these dimensions are folded determines the laws of physics. Here's the problem. There are not a few possible foldings. There are an absurd number, possibly 10 to the power of 500. Each configuration corresponds to a different universe, different constants, different forces, different outcomes. This is called the string theory landscape. At this point, the multiverse stops looking optional. It starts looking inevitable. Now let's confront the criticism. Where is the evidence? That question matters. We may never directly observe other universes. They could lie beyond our cosmic horizon, forever unreachable by light or information. That makes the multiverse deeply uncomfortable for science, because science prefers testability. If something cannot be tested, does it belong in physics or philosophy? Physicists are divided on this, and they should be. But here's the problem. The multiverse explains something that otherwise looks absurd: fine-tuning. The constants of nature appear precisely set for complexity and life. Change them slightly, and stars never form. Chemistry collapses, structure disappears. In a single universe model, this looks like an impossible coincidence. In a multiverse, it is statistical selection. We observe this universe because only universes like this can host observers. No intention, no purpose, just probability. That explanation is powerful and deeply unsettling, because it strips away the idea that reality was designed with us in mind. If the multiverse is real, then somewhere there are universes with no life, others with different forms of life, others where intelligence never emerges, others where it surpasses us. There may be universes where Earth never existed, where humanity vanished early, where physics allowed outcomes we cannot even imagine. There may even be universes where this exact video exists, and others where it never could. At some point, the discussion stops being scientific and becomes existential. If infinite versions of reality exist, what gives meaning to any single one? Here is the quiet answer. Meaning does not come from uniqueness. It comes from experience. You will never experience the other universes. You are locked into this one, this timeline, this outcome, and that makes it matter. The multiverse does not erase meaning, it relocates it, not in the cosmos, in consciousness. So where does this leave us? The multiverse may be real, it may be wrong, it may be undecidable. But its existence as a serious scientific idea tells us something crucial. Reality is not obligated to be intuitive. The universe does not care about human comfort, and our place in existence is far less central than we once believed, and yet we are here, asking the question. And sometimes, standing at the edge of what can be known is the most honest position science can offer. If you've made it this far, you're not just curious, you're willing to question reality itself. The multiverse may be real, it may be wrong, but the fact that science is even asking this question changes how we see existence. If this kind of exploration matters to you, if you want to keep pushing the edge of what we know, make sure you watch the next videos. We don't chase hype here, we chase understanding. This is Curio Logic. Question deeper, think sharper, because the universe might not be the only one, and we're just getting started.